Welcome back to Think Design Work Smart. I'm Alex Bolboaca and I'm coming at you from the Mozaic Works studios. And what I have for you today is a discussion about different databases that we can use for software development nowadays. This topic comes because I've noticed with our customers that very few software developers are familiar with the types of databases that we have in 2024 and 2025 soon. I believe it's very useful to at least know a little bit about them. Before we jump into the topic, I feel like I need to give you a quick update. If you've seen my latest two videos, you may have seen that the situation in Romania has been kind of crazy for a couple of weeks. And right now, what's happening is that we have delayed the crisis. I'm not sure we have averted it, but at least it's delayed probably until around March of next year, which means we can go back to business as usual until things change. And I'll be sure to let you know if anything else happens that can affect the channel. But I really hope that we can continue publishing one post per week, one video per week, as usual, next year as well. And perhaps even more varied content. I'm thinking about running some live streams. If you are interested, let me know in the comments, like programming, architecture, things like that. Let me know what you think. But now let's move to the topic at hand. In order to discuss this topic of databases, I have found this article. I've known about this thing for a long time, 7 databases in 7 weeks. This is also a book, and it's a very interesting idea. So the basic idea is that you learn how to run different databases and how they are different by installing, configuring, doing things with them. So let's see what the author Matt Blewett has to say. I've been running database as a service for a long time, and there are always new things to keep abreast of, new technologies, different ways of solving problems, not to mention all the research coming out of universities. In 2025, consider spending a week with each of these database technologies. And honestly, I will advise you to do that. I think there's a lot to learn about the database technologies. There are a lot of different things that come up here. These are, as he's saying next, these are not necessarily the best databases, but these are different types of databases. These aren't the 7 best databases or something similar to Power BuzzFeed listicle. These are just 7 databases that I think are worth your time to really look into for a week or so. You might ask something like, why not Neo.js or MongoDB or MySQL Vitess or insert another DB here? The answer is mostly that I don't find them interesting. I'm also not covering Kafka or other similar streaming data services. Definitely worth your time, but not covered. Right, so in case you are an architect or a senior developer or a software engineer, you should know the different types of databases. This is what I believe, at least what's possible, right? So let's see what he mentions. PostgreSQL, SQLite, DuckDB, ClickHouse, FoundationDB, Tiger, Beetle, CockroachDB. And let's talk a little bit about each of them. PostgreSQL, the default databases. PostgreSQL is the pinnacle of boring technology and should be the database you reach for when you need a client-server model for your database. ACID compliant, plenty of interesting tricks for replication, both physical and logical, and incredibly well supported across all the major vendors. My favorite feature of Postgres, however, are extensions. This is where I feel Postgres really comes alive in a way that few other databases can. There are extensions for almost everything you could want. AGE enables graph data structures and the use of the Cypher query language. TimescaleDB enables time series workloads. Hydra Columnar provides an alternate columnar storage engine, and so on. Postgres shines as a great default database for that reason, and we're seeing even more non-Postgres services rely on the Postgres wire protocol as a general-purpose Layer 7 protocol to provide client compatibility. With a rich ecosystem, sensible default behavior, and that it can even be fit into a WASM install makes it a database worth understanding. So, in case you haven't caught that, it seems that Postgres can be installed in a WebAssembly setting, which is basically running it in the browser. Or another option is to use WebAssembly for microservices, because WebAssembly is by default sandboxed. And this allows your microservices to be more secure because they are sandboxed. So that's interesting. But this also gives already a few interesting things that I'm not sure you are aware of. You might need graphs. You might need graph databases for certain things. You might need time series workloads. If you have data that comes in, a time and something that happened at that specific time, it's a specific kind of data storage. And the way you store data can improve your performance depending on the type of queries that you're using. Now, maybe you have people looking into this, but I still think it's useful to know what's possible. Also, one of the things that I've noticed in many enterprise environments, they tend to be very closed to different technologies, which is understandable because adopting a new technology in an enterprise environment comes with a bunch of things. You need to ensure security, you need to ensure upgrades, maintenance, you need to know who to sue in case things go wrong, and so on. So there are a bunch of things that are important. However, if you really want the best solution for your product in an enterprise ecosystem, then the only way to make this sell to your IT department and your legal and whoever else is involved is by knowing precisely what you need, why you need, and so on. So that's why it's very useful to try them out. Okay. So what he says is, spend a week learning about what's possible with Postgres, but also some of its limitations. Multi-version concurrency control can be fickle. Implement a simple CRUD app in your favorite language, maybe even build a Postgres extension. Okay. SQLite. Now, in case you don't know, SQLite is an amazing database. I really love it. SQLite is a one library that is available for all programming languages. And you basically install that library and you have a database. And it's included in the engine is actually compiled or, included in your package. And SQLite is, it can run in memory, which is great because you can have very quickly an in-memory database that you just work with. You can also use a file By default, it doesn't have constraints enabled, so you can also use it in a very relaxed way if you need to, or you can enable constraints if you want it to be more like a relational database. So it's really great. It's really great to start. It's really lightweight. Now, of course, if you have, I don't know, billions of data points, it's probably not the right one. But for many applications, I think SQLite can just do great. So let's see what he's talking about related to this. Moving on from a client-server model, we can take a detour into embedded databases, starting with SQLite. I've turned this the local first database where the SQLite database is directly co-located with the application. One of the more famous examples of this usage is WhatsApp, which stores chat as local SQLite databases on the device being used. Signals also does the same thing. It makes sense, honestly. Beyond that, we are starting to see more creative uses of SQLite rather than just a local ACID compliant database. With the advent of tools like Lightstream, enabling streaming backups, this is incredible. So SQLite to the Lightstream, you can basically back up, so it writes into your a local file, right? But you want to back that up. You can back it up to, let's say, an S3 bucket using Lightstream, and it will just do it by streaming. So upon every change, it stores the changes and it can run them. And it's incredible to do that, you know. And LightFS to provide distributed access. So this is a file system. We can devise more interesting topologies. Extensions like CR SQLite allows the use of CRDT. So what's that? Conflict-free replicated data type. To avoid needing conflict resolution when merging chain sets as used in corrosion. So you can basically scale it through synchronization or replication. SQLite has also had a small resurgence thanks to Ruby on Rails say 37 Signals has gone all in on SQLite. Yeah, I mean, that sounds like 37 Signals, picking the lightweight technology. Building a bunch of Rails modules like SoliQ and configuring Rails to manipulate multiple SQLite databases via database.yml for this purpose. Blue Sky uses SQLite for the personal data server. Every user has their own SQLite database. Spend a week experimenting with local first architecture using SQLite, or even seeing if you can migrate a client-server model using Postgres to something that just needs SQLite instead. I really love. So SQLite is one of my favorite databases. I've used it for a long time. I know about it, and it's often my default choice when I can make a choice, at least for starting. Because it's just no fuss. You set some, it works by default, so you basically install a library in your application. You define the name of the database file and it just works, you know. And then you can do additional things. You can keep adding to it if you need more things. Of course, as I said, if you have billions of data points, probably not the right one. If you have a complex setup, probably like specific data, like vector databases, I don't know, or RDF, probably not the right one. But if you just need a database for a project, yeah, it's great. DuckDB, the query anything database. On to the next embedded database, we have DuckDB. This one I don't know, I have never used it. Much like SQLite, DuckDB is intended to be an in-process database system, but more focused on online analytical processing versus online transaction processing. Where DuckDB shines is its use as a query anything database, using SQL as its dialect of choice. It can natively pull data into its engine from CSVs, TSVs, JSONs, but also formats like Parquet. Just check out the list of data sources. This gives it extreme flexibility. Check out this example of querying the Blue Sky Firehose. Okay. I have no idea what Parquet is, but apparently it's a data format. Much like Postgres, DuckDB also has extensions, though not quite as rich an ecosystem. DuckDB is much younger after all. Many contributed by the community can be found at the list of community extensions, though a particular favorite of mine is G-Sheets. I imagine this is just G-Sheets. Read and write Google Sheets using SQL. Okay. All right, that's cool. Spend a week doing some data analysis and processing with DuckDB, be it via a Python notebook or something like Evidence. Maybe even see how it fits in with your local first approach with SQLite by offloading analytics queries of your SQLite databases to DuckDB, which can read it. So if I understand correctly, this one is, let me just quickly check. Query and transform your data anywhere using DuckDB feature-rich SQL dialect. Yeah, I mean, this looks like SQL. Runs on different things. So basically you can carry CSV, Parquet, and JSON. Let's see. This is quite interesting. Start with relational. Let's see the formats. Where are the formats? Feature, fast, extend, free. Peer review, other. No. I thought they would be formats. Okay. So portable, feature rich, SQL dialect, fast, extensible, free. Yeah, so you basically install it. This looks really great. And once you install it, you can run queries on CSV, on various things. Cool. And with G-Sheets, you can run queries on your Google spreadsheets, which is basically using spreadsheets as a database. That's actually something that I've been looking at. We have a bunch of CSV files, and I was wondering how could I use them as a database without doing much work. And this sounds like one that I'd like to try. All right, ClickHouse, another one I haven't heard about. Leaving the embedded database sphere by sticking with the analytics theme, we come to ClickHouse. If I had only picked two databases to deal with, I'd be quite happy with just Postgres and ClickHouse, the former for OLTP, the latter for OLAP. ClickHouse specializes in analytics workloads and can support very high ingest rates through horizontal scaling and sharded storage. It also supports tire storage, allowing you to split hot and cold data. GitLab have a pretty thorough doc on this. Where ClickHouse comes into its own is when you have analytics queries to run on a dataset too big for something like DuckDB, or you need real-time analytics. There is a lot of benchmarking around these datasheets, so I'm not going to repeat them here. Another reason I suggest checking out ClickHouse is that it is a joy to operate. Deployment, scaling, backups, and so on are well documenting, even down to setting the right CPU governor is covered. Oh boy, that's great. Spend a week exploring some larger analytics datasets or converting some of the DuckDB analytics from above into a ClickHouse deployment. ClickHouse also has an embedded version, CHDB, that can offer a more direct comparison. Okay. Let me quickly check ClickHouse. So real-time data warehouse, analytics and observability. This sounds like it would be really useful for things like aggregating logs and checking them out. I think that could help. And I know in enterprise systems, you usually have things like Grafana, Prometheus, but you might need to query some things that are not there, or or maybe if you are working in a smaller company and you don't have those, something like DuckDB, something like ClickHouse might actually work, right? I'm sure there's a use case for that. Okay, Foundation DB, the layer database. Now, by the way, when they say columnar database, this means that the data is stored in a different way, which makes it better for analytics. That's an interesting thing. One of my first projects in C++, and actually one of my formative projects in C++ has been a columnar database engine. So I know a little bit more about these things than most developers. Foundation DB, the layer database. We now enter the mind-expanding section of this list with Foundation DB. Arguably, Foundation DB is not a database, but quite literally the foundation for a database. Used in production by Apple, Snowflake, and Tigris Data, Foundation DB is worth your time because it is quite unique in the world of key-value storage. Yes, it's an ordered key-value store, but that isn't what is interesting about it. At first glance, it has some curious limitations. Transactions cannot exceed 10 megabytes of affected data, and they cannot take longer than 5 seconds after the first read in a transaction. But as they say, limits set us free. By having these limits, it can achieve full IC transactions at very large scale. 100 plus terabyte clusters are known to be in operation. It's not terabyte, it's, I think, tera, I don't know what TB is. Foundation DB is architected for specific workloads and extensively tested using simulation testing, which has been picked up by other technologies, including another database on this list, and Antithesis, founded by some ex-Foundation DB folks. For more notes of this, okay. As mentioned, Foundation DB has some very specific semantics that take some getting used to. Their anti-features and features docs are worth familiarizing yourself with to understand the problems they are looking to solve. But why is it the layer database? This is because of the layers concept. Instead of tying the storage engine to the data model, the storage is flexible enough to be remapped across different layers. Tigris Data have a great post about building such a layer, and there are some examples such as a record layer and the document layer from the Foundation DB organization. Spend a week going through the tutorials and think about how you could use Foundation DB in place of something like RocksDB. Maybe check out some of the design recipes and go read the paper. Okay, so now this one is mind-boggling. It's very scalable. It's open source. Okay. Can store all type of data, can easily scale and handle hardware failures, industry-leading performance, flexible application architecture. Application can talk directly to Foundation DB, to a layer, or both. Oh, this is interesting. So I don't know exactly what this talks about, but yeah, I imagine you can do, with layers, you can have basically different views on the data, I imagine. Anyway, sounds very interesting. I don't see for myself a specific case. But this sounds very interesting. Okay. Down to number 6, Tiger Beetle, the obsessively correct database. Flowing on from the deterministic simulation testing, Tiger Beetle breaks the mold from our previous databases in that it is decidedly not a general purpose database. It is entirely dedicated to financial transactions. Interesting. We have a lot of customers from banks and financial organizations, and they have switched to microservices architectures, but one of their challenges there is that they need to do distributed transactions. So if some of it would be solved by a data engine, that would be interesting. Why is this worth a look? Single-purpose databases are unusual, and one that is as obsessively correct as Tiger Beetle are true rarity, especially considering it is open source. They include everything from NASA's Power of 10 rules and protocol-aware recovery through to strict serializability and direct input-output to avoid issues with the kernel page cache. Jeez. So I remember learning about databases in university, and I was really fascinated. I read from the library, there were two huge books written by Ullman, and they were talking about everything related to databases, from the logical level up down to storage and the way to store things and so on. And this is some really crazy stuff. This is crazy stuff. Direct input output to avoid issues with the kernel page cache. This is really something. It is seriously impressive. They'll just go read the safety doc and their approach to programming they call Tiger style. Another interesting point about Tiger Beetle is that it's written in Zig, a relatively newcomer to the system's programming language school, but clearly has fit well with what the Tiger Beetle folks are trying to accomplish. Spend a week modeling your financial accounts in a local deployment of Tiger Beetle, follow the quick start, and take a look at the system architecture docs on how you might use it in conjunction with one of the more general purpose databases above. Let's see the safety doc a little bit. This is incredible. Strict consistency, handles and recovers from latent sector errors. Detects and repairs disk corruption or misdirected I/O where firmware reads, writes the wrong sector. Detects and repairs data tampering. Are you kidding me? Uses direct I/O by design. Exceeds the F-sync durability of a single disk. Provides strict serializability. Performs synchronous replication. Is fault-aware. Recovers from local storage failures in the context of the global consensus protocol. Are you kidding me? Tiger Beetle does not depend on synchronized system clocks, does not use leader leases, and performs leader-based timestamping. Are you crazy? This is, wow. This is impressive. I had no idea this exists. You see, this is why it's so interesting to see. Let's see the system architecture a little bit. You have an app, you have stateless API, you have a general purpose database, and you have a database cluster. All right, man, this is impressive. You see how I don't get excited about AI that much, but how I get excited about database systems. Well, to each their own. Okay, and number 7, CockroachDB, the global database. Finally, we come full circle. I struggle a little on what to put here in the last slot. Thoughts originally went to Valkey, but FoundationDB scratched the key value each. I thought about graph databases or something like ScyllaDB or Cassandra. I thought about DynamoDB, but not being able to run locally for free put me off. In the end, I decided to close on a globally distributed database, CockroachDB. It's Postgres while protocol compatible and inherits some of the more interesting features discussed above. Large horizontal scaling, strong consistency, and it has some interesting features of its own. CockroachDB enables scaling a database across multiple geographies through being based on Google's Spanner system, which relies on atomic and GPS clocks for extremely accurate time synchronization. Are you kidding me? Sure. I mean, now that I'm reading this, I realize that timestamps are incredibly important when you want to distribute databases. And this requires synchronized clocks. So, yeah. Commodity hardware, however, doesn't have such luxury, so CockroachDB has some clever solutions where reads are retried or delayed to account for clock sync delay with NTP. Yeah. And notes also compare clock drift amongst themselves and terminate members if they exceed the maximum offset. Yeah. That makes sense. Yeah, time is very important for these things. Another interesting feature of CockroachDB is how multi-region configurations are used, including table localities, where there are different options depending on read-write trade-offs you want to make. Spend a week re-implementing the mover example in a language and framework of your choice. What's the mover example? Let's see. Mover is a fictional vehicle sharing company created to demonstrate CockroachDB's features. The mover example consists of the following: the mover dataset, which contains rows of data that populate tables in the mover database. The mover dataset is built into the Cockroach demo on Cockroach workload. The mover application, a full functional vehicle sharing application written in Python. The 6 tables, okay. Right, so it's basically yeah, I work with a company that was doing things like this, and localization, yeah, there are some important things here. Okay. So what are my thoughts after this? I think that, as I said, it's very important for software architects to know what type of databases exists, but also for senior developers, senior software engineers, because you may need to solve specific problems, and sometimes it's just easy to solve those problems by using the right technology. And knowing more databases, as you've seen, there are some incredible databases here, and this is just scratching the surface. There are a lot of other technologies, but they all fit in various categories. So once you know one from each category, you can then pick ones that are useful for your specific technology, so, or for your specific problem. So I think it's really useful to do that. Now, what are your thoughts about it? Have you tried any of these databases? Are you using any, let's say, weirder database engines for your products? Let us know in the comments. Also, let us know if you like to see some, let's say, a monthly development or architecture stream. We might try this next year. All right, we love comments, so yeah, thank you so much for the comments that you added for in the past 2 weeks and the messages that I got. Yeah, thank you. It's been great. All right, with this being said, thank you kindly for the view, and until next time, remember to think, design, and work smart. See you next Saturday.